Hi, I'm Cheryl Lemke. I'm the evaluator for School2Home, and I'm here to report to you on some preliminary findings that we have from a study we're doing on math and technology in underserved middle schools, what works. I'd like to thank the California Emerging Technology Fund and School2Home for commissioning the study. So what was the impetus for the study? Well, there were two things. One is that we were seeing consistently low math scores in the School2Home partner schools over the course of several years. And then the second one is that we were reminded about the importance of middle school mathematics and algebra for college and career readiness, for future productivity and jobs, and for higher wages. So how did we conduct the study? Well, one is we did several literature reviews on research-based practices related to math achievement in underserved populations. We focused on middle schools and we looked hard for those studies that actually used digital learning and technology as well. And so we did report on that. The second thing that we did is we looked around California and said, who's beating the odds? We gathered the files from the California Department of Ed on the 2019 math scores. And so we took all the schools in the state. We filtered then for those schools that were serving middle school or junior high. And then we filtered for all the schools that had at least 60% free and reduced lunch because we were looking for underserved populations. And then the third thing we did is we looked for those schools that were beating the odds in terms of academics, the fact that they were actually meeting or exceeding the state average in math scores for middle schools, that 37.7% proficient. And so then we contacted each of these 21 schools and we asked if we could interview a teacher and an administrator. And we're still in the process of collecting the data for those studies, but we do have some preliminary findings. And from the literature review, what we found is that middle school mathematics can be a gateway into a lot of STEM career opportunities and into advanced mathematics in the high school, or it can be a gatekeeper that actually is a stopper, and it slams the door shut for those students who don't do well in mathematics in middle school. And this is especially true for a large population of African American and Latino students, as well as for English language learners. So we looked at a couple things when we were looking at the studies. One was, what are the indicators that would suggest that kids were on the right track? And no surprise to you, some of it is just passing your math courses. Another one is actually meeting those math benchmarks on state exams that we see across the state a lot of kids have trouble with. And then the third one is passing algebra in the 8th grade. We also looked at a fairly large California study that had some really interesting findings. They looked at thousands of schools, and what they found was that how kids did in 7th grade was in math was very predictive of how they would do in high school, what courses they would take, and how well they would do in those courses. And we found that students who passed Algebra 1 by 9th grade were twice as likely to graduate. And then we also looked at excelling in mathematics as kind of a social justice issue. We looked at the Office of Civil Rights, and they had some studies about math in 2015-16. And what they found is that Black and Latino students were underrepresented among those taking algebra in 8th grade. So here's how we framed the study. We decided to put up a profile of the students that are successful in mathematics. So what learning strategies do they do? We know that we all have the state mathematics standards that are there, but what are the learning strategies that these students use in order to excel in reaching those standards? The second one was we looked at high impact instructional strategies that teachers might use to actually make sure that kids reach that profile. And included in that are effective practices with digital learning. And then finally, for principals and leadership teams, we looked at what are the leadership strategies that would really advance math achievement in the school? What could they do in that leadership capacity to advance that? So the first thing we're going to do is look at the profile. But before we look at what we found in the literature review, we'd really like to hear from you. You're out there in schools every day. So we would like you to go to this site. And when you get there, it's going to look like this. Put in this code, and it will ask you for 3 words or phrases that describe a good math student. So I'm going to give you a few minutes to do that, and then we'll come back and look at the results. Okay, so just pop over there and see what's going on. And here we have it. A lot of you have already typed in your information, and you all know how word cloud works, that the larger the word, the more people who have typed in that information. The top one is persistence, that they've got that grit to stick with it and make it happen. Determined, diligent, curious, growth mindset, organized, detail-oriented, courageous, open-minded, willing to try, tries harder, tries and tries again, pays attention to detail, is invested, sees the big picture, is motivated, learns from mistakes. These are great. These are really wonderful, and they align so well with the profile that we've put together from the literature. So let's go back to that. There we go. So we have put together a profile of the learning strategies that successful math students use. The first one is about a mathematical mindset. And that means that students have this open approach of excitement and motivation as they begin to study mathematics, that they see it as a science of patterns that they're interested about and they're curious about, and they have a desire to really understand it. They also, we also think that mathematical mindset, and mindset, stems from growth mindset, that they have the confidence to know that through effort and hard work that they can succeed in mathematics. We also have when you have a mathematical mindset, you also have kind of an idea that what mathematics is about is not necessarily just memorizing things and algorithms. It's really about making sense about the world around you. And so that students who have a mathematical mindset see math everywhere. They see it when they play soccer. They understand that they are projecting some measurements as they're kicking the ball, as they're trying to score a goal, that they see it in the area of music, that it's frequencies, and that's all about mathematics. And they can actually see that no matter what problem that they run into, they can solve it through mathematics. The second one is really about learning conceptually as well as procedurally. And we know that a lot of students think that all mathematics is trying to get the right answer, that it's all about computation and all about algorithms, that they just have to figure out which one to use and plug things in and calculate it out and see if you can get the right answer. And that's not what it is at all. It's really those big ideas in math that are concepts, and they can understand it. So let me show you a quick video that kind of shows you the difference between procedural math and conceptual math. So let's go take a look. Oops, that's the wrong one. There we go. Sesame Street. We all love Sesame Street, right? So take a look and see if you can see how they use procedural and conceptual math.
The phone. I'll get it. I get it. Oh, man. Oh, hold on. It's for you, Humphrey. Mm-hmm. Here you go. Thank you. Hello, furry arms. How may I help you? We're hungry. Well, what would you like? A fish. Fish. A fish. 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 How about you guys? Fish. 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 You got it? Well, let me repeat that. Fish, 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 fish. You got it. All righty. Be right up with that order, Mr. Penguin, sir. Yum. Ingrid, go tell the kitchen. Fish, 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 fish. Fish, 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 fish. No. Fish, 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 fish. Not that easy an order, but I'll get it. Excuse me, Ingrid and Humphrey. I have a better way for you to do this. A better way? Mm-hmm. What do you mean? Well, I just think it would be easier if you, count the fish. count them? Really?
Look, I'll show you. Humphrey, you tell me the order, and I'll count with you.
Alrighty. Fish.
1,
Fish.
2,
Fish.
3,
Fish.
4,
Fish.
5,
Fish.
6. See there? See what I tell you? Now you know how many fish to send up. 6 fish.
Holy mackerel! This counting thing can really save a person a lot of trouble.
Yeah. Does it work on other stuff? Say cinnamon rolls? Cream pies?
Sure.
Spark plugs?
Absolutely.
Wow.
Wow!
He
did it again!
He may be the smartest person in the whole world.
I hope you enjoyed that. And I hope that you saw that the difference between procedural and conceptual math, that in counting, we look at the procedural in terms of memorizing what those numerals are and actually understanding what order they are. But when we get into the conceptual idea of what a number means, it means that we can transfer it from area to area. So for example, Humphrey was saying, well, okay, I can count fish, but could I use it in other ways? Could I count cinnamon rolls? Could I count spark plugs? And that's what we want our kids to do, to be able to understand deeply what that concept is about and be able to transfer it to other areas, And so I thought it was a really cool kind of idea about how to differentiate between concept and procedure. And one of the reasons that we want kids to understand concepts is because they can transfer to other things. I also wanted to just share with you some notes from one of the interviews that I did this is a math teacher in a Beating the Odds school that has 86% free and reduced price lunch, and they're at 38% proficiency, so just above the state average. One of the things she said to me when I was interviewing her, I asked the question, how are you doing this? How are you beating the odds? What is really important that you do every day in your classroom? And she said the single most important thing she does is to help kids understand math conceptually. That it's important to see that students see multiple approaches to solving problems, that they create their own solutions, that they create opportunities for those aha moments when a light goes on and a student actually deeply understands it. And how do you get kids there? Well, one of the things that you do is you don't give them worksheets every day with 10 problems on them that they have to compute. Instead, what you do is you begin to ask more open-ended questions where students are actually playing with the math concepts and sketching and drawing and color coding and trying to figure things out. And then as they do that, feeding that back to either a peer or the teacher. In this case, this teacher actually does a lot of collaborative learning, but they also assign, notice here she says, I assigned less problems and show and explain their thinking. And so one of the things that she was talking about is having her kids go on Flipgrid and actually do a video where they actually use these sketches and drawings and color codings as props, and then they explain how they got the answer to the question, which is really powerful. So conceptual math. Another one I thought I might share with you is, this is a book that actually was written by Robert Polinsky. Those of you in math probably know his name. And what he does is he actually has these problems, these open-ended problems that actually get his kids in to kind of play with the information. And I just pulled one of the examples that he had here where the kids are learning fractions. And so the first problem is just find the quotient. And what kids obviously do is they take the reciprocal of 3/5 and multiply, and they get the answer. And they can do worksheet after worksheet of these, but without really understanding what they're doing. So one of the things he had them do in the second one is using the digits 1 to 9 at most one time each, place a digit in each box to make two different pairs of fractions that have a quotient of 2/3. And so all of a sudden they've got to figure out, well, what kind of a number do I have here when I kind of randomly put something in there? And am I going to, if I divide by a number smaller than 1, is it going to increase the size, or should I divide it by a number that's larger than 1? And how do I go about doing that? So they play with these things. Now you can do kind of trial and error, but that's a lot of numbers. numbers and a lot of combinations. And so eventually what kids do is they see some patterns and they're able to actually share their path. And then the third one, which he always tells them is almost impossible, which of course kids love to get challenges, is to actually take this set and use again the digits 1 through 9 and place them in here so they get a fraction that is close to 4/11ths. And this one really takes a lot of information. And the other thing that Polinsky suggests is that kids do this actually in teams, so they can kind of share what they're learning as they go. And it's this kind of thing that you kind of get in them. I had another one that I deleted and probably shouldn't have, where like, for example, in the use of geometry, if you're studying things like squares and rhombuses and so on, one of the ways to see if kids really understand it is to put a Venn diagram, to say to them, okay, we've got squares and rectangles and rhombuses and parallelograms. Now put them into a Venn diagram to show how they relate and how they're organized. Again, very open-ended, and kids have to really think about the definitions and what that means and how they would place it. So again, very open-ended kinds of things is what we're really looking for. So the third one, and I'm not going to spend a lot of time on all of these, but I thought these two were really, really important. And I might just mention that the way that we built these was through some key sources. One was the California Common Core Standards for Math. Another one was a book by NCTM that talks about principles to action. And then the Boulder book on mathematical mindset are three of the many resources we used. The third one is perseveres through productive struggles. And one of the things that we'll be talking about is how do you get kids to persevere? Well, you get the way that you do that is by engaging them, having them excited and interested in doing that, and actually having a classroom of kids that actually reinforce that piece of it. That means one of the research studies that we're talking about in the report talks about the fact that when you compare kids learning collaboratively, kids learning competitively, and kids learning individually, what all of the research shows that those kids who are learning collaboratively outperform those two other groups hands down. And yet we don't have enough of that collaboration in our work. So if you expect them to persevere, then one of the things that is really helpful is if they're actually working in collaborative groups. Another one discusses the arguments and does the critical thinking and the constructive responses. And this one is really important. And again, this has to happen in collaborative learning groups where kids actually come up with a solution and they're able to defend their solution or talk about their solution and explain their solution as they're doing them. The fifth one uses visuals and data analyses to solve problems and interpret findings. This one is so critical. Oftentimes kids look at they'll come up against a story problem and they'll look at it and they'll say, I have no idea how to do this. Or they'll pull all of the numbers out and try to multiply, add, divide, or subtract without any kind of rational thought about how they do that. But if you teach them to use visuals, then they can sketch it out and actually begin to understand before they actually even put the quantity in. And one of the teachers we talked with talked about the fact that he does that for solving problems. When his kids hit problems, they don't do anything with the numbers. They just sketch it out and explain it to each other and talk about it as you're going. The sixth one is thinking critically to solve real world problems. And that means that instead of just doing the problems out of a book, kids would actually do problems that actually matter to them. And it's not that hard to actually get problems that kids can solve. Like, for example, if you're doing some comparisons or ratios, you might even think about, well, what's the best cell phone plan for your family? And they have to do the math in order to kind of figure that out. So there's lots of ways that you can do that. You can also have kids actually make up their own real world problems as they go. And then the last one is learns math using technology. And excuse me, and we did a lot of analysis of studies on middle school mathematics and especially where we could find it underserved populations, and found that the majority of studies show that when kids are using technology and digital tools, that the scores go up. So and that is actually in the report. The next thing we did is we actually went in and said, well, if that's what we want for kids, then what are the teaching strategies that would have to go with that? And so what we've done is we've actually established from the research, and we went to I don't know if you've seen it, but the California Common Core standards have implementation guides. And so we looked at those. We looked at the National Council of Teachers of Mathematics, the Principles to Action, and we looked at mathematical mindsets and several other things. And here's what we came up with. One is to set high standards. Oftentimes we have different standards for different groups. And I think it's one of the reasons that it is one of the reasons that we actually have a number of subgroups that are not doing well in mathematics. And so we need to begin to say, every kid can learn, every kid can do this. And especially with if we could develop a mathematical mindset, those kids will begin to believe that as well, and begin to do both procedural and conceptual mathematics. So that one is really, really critical. Another one is to help students develop that mindset. And part of it is actually language that we use. You guys have probably seen growth mindset, which means that you don't praise kids for being smart and intelligent. You praise them for actually the effort that they put in and the strategies that they're actually thinking about and using. So it's about their work. And one of the other things in this one is actually the idea of setting goals and tracking progress. Research is very clear that when the curriculum is visible to kids, when kids see, oh, these are the California standards that we're expected to achieve this year, and here's what we're working on now, and here are the particular goals, and actually have kids set those goals or have the class in groups set those goals and then track their progress. And it's really important that we do that so that kids actually say, well, I haven't really demonstrated that I know how to, I really have a deep understanding of dividing fractions, but I do understand how to do it. I'm not sure that I can explain it well about why it works. And so if kids actually get into that phase of actually setting the goals and tracking their progress and knowing where they're at, they know then what they need to work on. I was in a class last spring before the pandemic hit, where what the school did is they had kids in 8th grade mathematics classes, and then they had a second class for kids who were very low performers. There were about 10 kids in that class, I think, who came in at a second hour, and they worked on any problems that they were having in their regular class, but then they also worked on Khan Academy and a variety of other things to actually kind of close the gaps that they were in. And in that one, I was really struck because all 11 kids had goals for the week that they were doing, and they were actually talking with this teacher about whether or not they met their goals and then resetting for the following week. So it's really important. Another one is building meaningful relationships. And this one is very important, intellectually safe culture. And that means that when kids make mistakes, they're not going to be ridiculed, and they know that, and they feel safe about sharing their ideas, even though they're not quite sure. Part of the way that we do that, I saw, this is a really interesting technique. I was in a classroom a couple of years ago where a teacher had a wall of words, and she had these words that talked about kind of the way that kids would get into explaining what they were doing. There were prompts, and for example, one of them was based on the information I have now, I think, or based on the analysis that I've done now, I think. What that does is it gives kids a way in to sharing what they're thinking now, but qualifying it by saying, I may change my tune tomorrow because I may have more information by then. What a great way to do that. And that wall of words was really powerful, and those kids were using it. It was pretty amazing. Those prompts are really important. Educate and engage parents in developing mathematical mindsets. One of the things that I was in on a site visit. This is about a year ago. And one of the, there was the social emotional kind of thing going on where kids were disagreeing, and then they were doing conflict resolution. And I was so impressed with the way the school handled it. And then once we were walking around campus afterwards, one of the principal said to me, well, it works really well when we're here, but of course it's a different environment when kids go home. And so they're getting mixed messages. And so one of the things we're suggesting here is that you engage parents in developing those mathematical mindsets and helping them to understand not to tell their kids that they're smart, that they're the next Picasso, but instead honor them by thanking them for the effort that they put into the work that they're doing, especially in mathematics, but really in all of the work, and understanding why mathematics is so important, and understanding that math is more than computation, and that it's really important that they understand the conceptual piece. The fifth one is facilitating the collaborative math discourse. And this one, the only thing I'll say about that, I've already talked a little bit about that, but the only thing I'd like to say is that it's really important that when kids do that, that they use the language of mathematics. I was talking with a teacher, my last interview was just a couple of days ago, and he was telling me that one of the most important things that he puts forth is rigor. And the reason that he does that is because he wants his kids to be using the mathematical terms and vocabulary and understanding that. And there are times when you use these very informal approaches to reading things, and that gives you an incorrect analysis of what that term really is. So he's expecting them to use quotient and reciprocal and so on. Which is again really important. And then finally, the last three are assessing evidence of student thinking and providing timely and relevant feedback. This one is really interesting. There's a new series in Ed Week by Harvard researchers, and one of the first ones that they posted was in January of this year. And what she said is, that schools are spending extraordinary amounts of time and energy analyzing student data, and they're not doing anything with it. So they analyze all this data and they say, oh, kids are this way, kids are that way, but then they don't actually make it actionable. They don't actually take it and say, okay, based on that data, I'm going to change up this, I'm going to change up that. And let me, and it's sometimes it's fine-grained things and sometimes it's larger things. One that comes to mind that I was in a school, this is actually in Philadelphia a few years ago, where they were looking at their test scores, and what they were finding is that their sixth graders could not identify a right angle or a right triangle. They're going, what? We've been doing right triangles for a long time. And what it was is the right triangle, when it's shaped and positioned like this picture is on the screen, they understand, half of it, they understand what a right triangle is. But if it's tilted at all, they don't understand it, because the only thing that we presented to them is actually in that particular position. So think about that. And then provide opportunities for students to develop the learning strategies in the profile. So go back to that profile and think about that. And then the eighth one is, I can't see it. Let me see if I can move this. There we go. And then the last one is engaging students in learning math using digital tools. And that's the next area that I want to talk about with you. We've done a lot of research about technology. And I thought I would just share with you that the National Council of Teachers of Mathematics took them a long time to do this, but they are now have an official position that kids really do need to start using technology and other tools in math. And when the math standards were revised in 2010 in California, they did the same kind of thing. So they incorporated this standard in as one of their practice standards in there. So strategies to improve effectiveness. I don't know why that one does that. And what we did is we actually looked at, you can see my list of sources up here. We looked at meta-analytic studies. We looked at research handbooks. We looked at the Institute of Educational Science reviews, the What Works Clearinghouse reviews. We looked at WestEd's data because they're in California. And we looked at Michigan State, et cetera. So there's lots of data in there. And what we found are these things. One is when you use technology, it's much better to do it from a student-centered perspective rather than a teacher-centered perspective. And so that means that you allow kids to explore, you allow kids to ask questions, you make sure that the kids are active and engaged in it and not just plugged into a machine and having the computer actually guide them through whatever it is. And this was consistent over the last 10 years of research. When technology is used in a student-centered approach, kids are using projects, kids are using PowerPoint slides to present and create. Kids are using spreadsheets to create graphics. There's lots of different approaches that we need to use to make sure that kids are actually in charge of the technology and have agency with the technology. So, and it's also a motivation to them, if you want to know the truth. So that's one. A second one is this thing about collaboration, student collaborations that engage students in math discussions. And I've already talked a bit about that, but the research was clear when they looked at huge numbers of studies in terms of technology and middle school mathematics. And what they found is in those classrooms where there were collaborations as they were using the technology, kids learned more. And it also enabled them to enter into math discussions, which means the kids are talking about what they're learning. The third one is multimedia and visual resources and apps for student representation. What this one says is that when kids use visuals and they're using digital tools that are multimedia to understand things, their scores go up. Let me give you an example of that one real briefly. You guys all know Khan Academy. I'm just going to show one of the a quick video on that. So let me make this big. And what I'd like you to do is to think about it. Think about how you were taught how to divide fractions and whether or not it made any sense to you. Does it make any sense to you even now? Can you take 8/3 and divide it by 1/3? And what does that even mean? So watch this.
Take 8/3 and divide it by 1/3. So let me draw a number line here. So there is my number line. This is 0, this is 1, and this is 2, maybe this is 3 right over here. And let me plot 8/3. So to do that, I just need to break up my each whole into thirds. So let's say it's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So right over here, and then of course 9/3 would get us to 3. So this right over here is 8/3. 8/3. Now, one way to think about 8/3 divided by 3 is, what if we take this length and we say, how many jumps would it take to get there if we're doing it in jumps of 1/3? Or essentially we're breaking this up. If we were to break up 8/3 into sections of 1/3, how many sections would I have, or how many jumps would I have? Well, let's think about that. If we're trying to take jumps of 1/3, we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8 jumps. So we could view this as, do this in a different color, in this orange. So we took these 8 jumps right over here. So we could view 8/3 divided by 1/3 as being equal to 8. Now, why is this?
So I'm going to stop there, but isn't that enlightening? I mean, I found even as a former math teacher, I taught middle and high school, so I didn't do much of this. I did a little bit in middle school, of course, but I thought it was really intriguing about how the visualization actually happened. And so I think we need to oh, let me see if I can find this. I think we need to use visuals and push our kids into actually using multimedia digital tools in order to understand it. Sorry, I'm getting back to where I was. So view. Okay, so oops. So that's multimedia, and I actually was involved in a study that we did a few years back that's been published, and they literally said that you could increase test scores with kids who are doing higher order with multimedia by about 20%. So it's pretty amazing what the lights go on when they actually see it done visually. A fourth one is blended learning and digital supplements. What they found is that if they looked at the studies about where technology was being used in the classroom, it was more successful when the technology was used as a supplement to what the teacher was already doing in the classroom, versus actually having the kids do an entire Algebra 1 course, for example, online. So the supplement was really the best way to do that. And of course, in many cases, people call that blended learning. The fifth one is scaffolding kids when using apps. This is a pet peeve of mine. Oftentimes what we'll see is teachers who understand that they need to teach, like if kids are in 6th grade, they need to teach kids 6th grade mathematics, but then they have a lot of students who have these gaps to fill in the math. And so what they do is they put them on iReady or some other kind of program. And I think that's great, by the way. And there's diagnostics on it. They put them into the places that they don't understand. That's fabulous. But what teachers are not recognizing is that you can't just plug the kid in and let him or her use it for 20 to 30 minutes. You really have to go back and actually scaffold those kids as you go. And what the research shows is that the kids who do well in your math class will do fine when you plug them into iReady or something else. The kids but the kids who don't do well, your lower quartile, will struggle even when they're on this math piece. So you need to make sure that there's feedback loops from you. Plus, of course, there's always feedback loops from within the program. And that's kind of a major thing that we're actually missing. So actually, I'd take that one back to your school if I were you. A sixth one is the digital assessments to inform teaching and learning. And the only thing I want to say about it is just to reiterate what I said earlier, that the Harvard study shows that we're doing a lot of digital assessments, but we're not acting on the data that we get. And so it's really important to actually make sure that teachers understand how to act on it. Whoops. And then finally, the two last ones are moderate frequency to maintain student motivation. They found that that they were looking at schools, like for example, that we use iReady, and they would use it 30 minutes a day for the whole year, and kids would tune out. They found that when you actually mixed it up a little bit, and you maybe used iReady for a little while, then used Khan Academy for a little while, that kids would actually be much more engaged if it was fresh and new. So that was an interesting one. And then finally, this one is enabling student agency and self-regulation. One of the things that a big study came out of, it was a meta-analysis, and it talked about kind of the trifecta. If you really wanted technology to work in your classroom, you had to have three things. One is you had to have the collaboration that's there. A second one is that you had to have feedback loops, assessment and feedback loops to your kids, okay? And then the third one is that you had to have self-regulation. You had to give agency to your kids so that they could actually regulate a bit about what they're doing. And so these are 8 findings that we have, and And of course, we've got lots of, a lot more about them in the report that we're doing. So one last thing here that I thought we would share is kind of some information about the interviews. This is from a teacher in a California middle school that is 92% free and reduced lunch. But their math scores are 56.6% on average, which means that they're 18 points, almost 19 points above the state average. And what does she do? What she does is she actually uses blended learning and a rotation model. So this actually was an interview we did before the pandemic hit, but she had one-to-one in her classroom and she set it up in stations. And then she did a lot of her own Ed Puzzle videos that would teach kids concepts. So the kids in small groups would preview it and begin to be introduced to it. She had a station on closing skill gaps with, like I mentioned, the iReady, et cetera, and for short periods of time, of course. And then the teacher is working, so she's got a lot more instructional time with small groups. And she said that students really liked the model, that they came in, they got to work, they knew what they were supposed to do, they had goals in mind that they were trying to reach, and she said it really honors them with what they're trying to do. And I thought I would just share a few of these. I'm not going to read all of them, but we asked the question of what are the 3 key things? What's your secret sauce that allows you to be a school that's beating the odds? And these are the number of teachers that mentioned things. Collaborative discussions is huge in this. Blended learning and making sure that you use the technology and you use face-to-face. The conceptual learning was really big. And then the communicating and demonstration of reasoning, that you have to have kids show you what they understand and talk to each other about what they understand. And growth mindset, rigor, et cetera. So we thought those were interesting, and those are kind of explained in the report. And then I thought we also asked them, what's the app that you could not live without? And it was interesting to hear one of the important ones were apps that allows the teacher to view student work from a distance. So they mentioned Nearpod, Desmos, Whiteboard, FI, et cetera. They like Flipgrid. And you can see the list here. One of the people who was really adamant was about the Surface Pro. That this was a teacher who used almost no technology before the pandemic hit. And boy, was she in trouble when it hit. So she used a document camera to do all of the work that she was showing her kids. And so she said she went out and bought herself a Surface Pro, which allows her to use a pen and project to her kids so she can actually see online. So I thought that was really interesting. The other one that people talked a lot about is that they wanted to see student work from a distance. And so part of it is up here with viewing it through these apps. Part of it is down here where their kids have cameras that they can capture the student work and then send it off to them so they can actually see it. So lots more on that, but that's kind of there. And then let's see. One of the last things we're going to do is actually have you go in here and actually share one of the things that one way that your principal or leadership team is taking to close the math gap. So again, go to Mentimeter, different codes, and this is an open-ended one as well. We'd really like to hear, based on kind of where we're going and what we want for kids, what are you seeing your principal and your leadership team doing to actually support you so that your school is actually beginning to increase your math achievement? So I'll jump over there in just a second. Hopefully some of you are entering some things. I know it takes a while to do some thinking about it and to do some typing. Oh, working with partners and have math coaches. Absolutely. Virtual small group tutoring. I love it. One of the things that, in terms of coaching, one of the things that we've been reading in the research is that they've been doing some studies on whether it matters if the coach is on campus or is just kind of checks in virtually with teachers, and they found that it didn't make any difference, that had the same results. And so that's huge, because if you're using coaches, one of the things that you could do potentially is to have a series of coaches who actually have a cadre of teachers that they're working with, and do it online. Saves a lot of travel time if they're doing multiple schools, and yet you can kind of create that relationship. Looking at the research, it reaffirms that the IM program we're using plus the coaching is right on. Good. I'm glad to hear it. Virtual collaborative learning. Good. Support sessions almost every Friday, so we can request students who need extra help. That's huge, because they won't get behind then. Breakouts, Jamboard. In fact, this is a great collaborative tool, isn't it? It's one of the many, they actually mentioned that one as well in the interviews we were talking about. Continuing to collaborate and dedicating funding and other resources, and providing free tutoring. Great. So you're really, what it says to me is you're really already doing a lot of personalization, and making sure that that you're catching kids as you go. So thank you. And then the last one, and I actually am not going to spend a lot of time on this. You guys are probably very familiar with the leadership strategies, but I think there are some really important ones. One is that clear vision of math standards and sharing it with the community and setting those high expectations. That this one, I haven't interviewed very many principals yet. I'm hoping to this next week. But one that kept coming up in the few that I did was being able to delegate the responsibility for what needs to happen in mathematics and how that would happen with teachers. And so this principal happened to delegate, to build leadership among her staff who teach math, and then turn that over to them. So for a while, she said she would host meetings, she would have them come in, they would talk about some research-based strategies in math. And the thing that she always had them do is, before they walked out the door, they had to have something that was actionable. So you learned about this. So you talked about this. Okay, what are you going to do with it? And then the next time they came in, they reported out about what they did. And she turned it over to them. So they were responsible for kind of moving in that direction of mathematical mindset, for example. And in doing so, she said she had to kind of not be controlling, which isn't her nature anyhow, but allow risk-taking to happen, which is the next one. That culture of access, equity, and risk-taking. That, yes, you set a vision, but it has to be making sure that every child has opportunity, every child has access, and you think about the equity. And with the civil rights piece that we talked about at the beginning, that one is so critical, because it will make a difference for their entire lives. And so making sure that it's culturally responsive, that it meets the needs of those particular kids, that it's relevant for them so they are engaged. This one's an interesting one, and you kind of go, okay, but is it culturally responsive? And the thing I found when I talked to the teachers is that the curricula that they're using is not oftentimes both conceptual and procedural. Most of the teachers, when I asked them the question, said, oh, our curriculum is very conceptual, but I have to actually spend extra time doing the procedural, or vice versa. And the vice versa was really more the norm. High quality teaching on collegiality and coaching. And I talked to you a little bit about that. Rick DeFore did a really interesting article in Ed Leadership about this. And of course, he's all about professional learning communities. But he talked about the fact that we're trying to do so many different things with teachers. And in reality, we need to step back and support them and build their capacity to do this. And not have principals go in and try to teach, but instead have them have that collegiality. The sixth one, and the coaching is critical. The coaching is so important, and you know the literature is really clear on that. It's they said that, you know, in most of the recent research I've been reading, that coaching is more important than professional learning. And if you have to choose between them, do a little bit of this, but do a lot of this. Educate and engage parents, and we talked about that in support of math achievement. And then finally, the access to technology and making sure that we have information, to inform the teaching and learning. So I'm going to stop there. The assessments that inform teaching and learning, and making sure that once you do the assessment, that it actually does inform what's going on. And that's a really critical one. I actually was really surprised at the numbers on that from the Harvard person who has that column in Ed Week. And then finally, we thought we would allow you some time to actually get into groups and talk about one action from today that you're taking back to your school. And so I'm going to stop, and Steve, do you want to talk about how that will happen? And then we're only going to do this for about 5 minutes. We'll have you come back from your groups and report out, and then we're going to get out of here. So we'll be out within the next 10 to 12 minutes. Okay, so Steve, you're on. Okay. Hey, it's just going to be random. I'll just hit it, and then you'll get a button that says enter the breakout room, and you can do that. And then a little selfish plug here. Don't forget to follow us on at School2Home on Twitter. And as you go into your groups, we'd like you to report back when you come out, and we'd like to actually have one person put something in the chat, and then also open up your mic and report on it too. So that won't take long, it'll be quick.
So I guess we're a group. Who's on here with me?
Hey, I'm on here, Steve.
Hey, Steve.
Hey, how are you doing?
I see Lisa with us and Elaine as well.
Yeah. Now, what school are you? Oh, there's Rosa.
It's me. Hello.
I thought you were on the road.
I am.
Wow.
I'm taking you on the road with me.
Oh, is it Miss Peacock?
Yes, that's Miss Peacock.
Oh, okay. What's one thing that, what's one action you're going to take back?
I'll start. I liked her leadership skills, and I want to use some of those strategies in our SLT meetings so that when we leave our SLT meeting, everyone has next steps, and also after the next steps are noted on the agenda, asking them how might the members of the SLT support you in accomplishing this goal or this action item. That way there's more of a team, a sense of a team in there, you know?
Yeah.
I like that, that principle that she used where, you know, that they all walked away with one action item. So Miss Peacock, how do you like my idea in your SLT meeting?
Oh, it shows here. It shows here that she hasn't joined her breakout room.
So she probably stepped away from the computer.
That must be it.
But that's what I like.
This is a breakout group.
Well, boy, we're here. Come on, let's make the best out of it.
My breakout group, the breakout groups, when they said go to breakout groups, I said later because I didn't want to be in a breakout group. So I'm sitting here waiting for the group to come back together. You guys missed your cue on getting to your breakout groups. That's why you guys are stuck in here with me.
No, we're the hosts, Miss Peacock. That's why we're here. So, Miss Peacock, what action item are you going to take back? Or how did you like my idea about the SLT agenda? Do you think something like that'll work?
Yeah, I like that idea. I mean, I like Cheryl's presentations because she always gives so much information, and I'm listening to her and all the ideas for math and what works and what doesn't work. I'm just always surprised after 35 years of being in this district, how many young teachers don't teach that way or don't have those skills or don't do collaboration and
Right.
problem solving. That just surprises me all the time.
All right. So what
Yeah.
action item are you taking back, Miss Peacock?
I haven't decided yet. I have to think about that one.
Think about the same idea that I did with the next steps and how might we support you with your coaching sessions, with the coaching sessions that you're doing with your teachers, or even with your PD that you're doing with your teachers.
Mhm.
What are the next steps that they're going to take? Have that as an exit ticket, even, during PD. Have them, what are the next steps and how might we support you? Or what are your next actions and how might we support you in completing these actions?
Mhm.
That's something that'll you, because it's holding them accountable now, but you're also helping them, providing support.
Sorry, we didn't see the timer, so we weren't sure if we were going to be prompted back.
I didn't want to be late.
We just saw the timer right now.
Oh,
Sorry.
yeah. Not a problem.
Hi, Rosa.
Hello, how are you?
I'm good. How are you?
I'm doing well, thank you. Hello, Miss Yumi, Elizabeth.
Hello.
Steve, are you gonna open it up for us to type in the presentation or in the chat?
Oh, what we could do is, if you don't, we could put it in the chat, but we're going to break out and then have people share out.
Okay.
Either way, I don't think it's going to matter that much.
Alrighty then.
Thanks, Steve. That worked really well.
Oh, you bet.
So I think we're back. And what
I think, yeah. Oh, I'm sorry, Cheryl. You got about 55 seconds, and I think everybody will be back.
Okay.
Sorry about that.
No problem. I should have looked. It was fun. It was, and you're right. Small groups, make a lot of sense.
Yeah. Just easier not to get lost.
Yeah. How long did you teach math, by the way?
16 years. Well, 29 years because I did elementary too.
Cool.
Yeah.
Great. So as people are coming back, we'll wait for a couple more folks. I know everyone is dying to see if the fly makes a cameo again at the debate. And but I do want us to have enough time. I don't want to rush. I do want to take a good amount of time to get feedback from people to share the highlights from their conversations. And as we said before, this is not a one-time discussion. It's a pretty challenging issue that we're all dealing with. So there are going to be opportunities for you to continue to be part of the group, to plan these conversations. And if you cannot help with the planning, you're definitely welcome to participate in the conversation. So it'll be an ongoing process. I just want to note that. And I really want to thank you for taking the time today to join our discussion. And before we continue, I wanted to acknowledge our CEO, Sunny Wright McPeak. Sunny, do you want to say a few words to the group?
Thank you, Augustine. I want to just, excuse me, I started to choke. I want to thank everybody for participating. I see a lot of our colleagues that have been with School2Home over the years. And I see all different positions in the school leadership team. from Shani, who is a principal, to Raul, who is an assistant principal, the math teachers, Elizabeth Lester, who keeps moving around. And I also really appreciate, Cheryl, the time you took, and Augustine, the time that also the team took to refine the presentation for today. The genesis of what we're doing came out of the evaluation work a couple of years ago. And so one of Cheryl's 8 items in terms of what we're doing is you continue to do assessment to feed back into the work. It's not data collection in and of itself or for its own purpose, but actually to improve instruction that leads to improved academic performance. And 4 of our directors listened to a presentation a couple of years ago and said we should really focus on math, took Cheryl's recommendation. You've now taken it, Augustine, and made it come alive. And so I'm very appreciative of this. And if you all remember at the Leadership Academy earlier this year, when in February we actually physically were together, which was, when you think about it, a rare opportunity and a real benefit and a fortunate opportunity for all of us, that Dr. Patricia Rucker, who is on the State Board of Education, actually focused in on saying, if we want better math, then we need to focus on math as an activity, and that's what we're doing. So I appreciate this. I really enjoyed it. While I've never been a teacher, my husband has, and has been a math teacher. But actually, we met because he sat next to me in a calculus class the first day of college, and his only reason was for me to help him with his math homework. He had a girlfriend at the time, but I actually know how to count. So here we are, 50 plus years later. So I commend everybody for being on this, and thank you, Augustine, and thank you, Cheryl, and thank you to the 30 plus school to home leaders that have joined today. I really think this is a very important new dimension to the work of school to home.
Great. Thanks, then. Augustine, do you mind if we just do quick shout outs about what was discussed in the breakout groups?
Yeah, of course.
So let's have group 1. I think you saw your numbers pop up. So does somebody from group 1 want to share just a bit?
We'll just take in volunteers, people that want to volunteer. Yeah.
Good idea, Augustine.
Let me volunteer my group 7. Sorry, guys, I had to call you out. We did. They had good answers though. Please, so please, Sabrina and Taza.
Well, good afternoon. Sabrina Miller from Inglewood Unified School District, Crozier Middle School. So I am not a math teacher. I'm just a teacher of habit for our young people. And we were discussing about, the Clinton administration way back then, presented the No Child Left Behind Act. And in that, we tend to push kids right along, even though they haven't caught up. And we'll put them, like the speaker spoke earlier about, onto the iReady, and instead of integrate them into the blended learning. So we were discussing that. And although my children are out of school now, but I believe, and this is just my experience, that our teachers were bombarded with all of this Common Core, and it didn't get all of the skills to it. So then we switched it to our children, and then they didn't get it all. And so now we're so far behind in the math that it's really mind-boggling, because we can't, with the math, it's everything. You need math for adding your a cashier. You need it for car washing. You need it to get changed. You need it for everything today. And
I know Taza had a point too about in terms of the blended learning model.
Mm-hmm. And that was speaking to the section of the strategies to improve effectiveness in distance learning. For me, my takeaway was the blended learning model, where the teacher, the rotation stations. The biggest takeaway was making sure that our blended learning is strategic and intentional, and that our students are able to get that time. Even through virtual stations, rotations can be done with the breakout room. So just really, again, making sure that that blending learning, even with all the tools, is strategic and intentional to meet the needs of the students.
Thank you.
Thank you.
Group two, I'll let one of my peers, either Leah or Catherine, share, and then I'll go after them. Or Mr. Duran, are you able to speak now? Can we hear you in the main room? We couldn't hear him in the breakout room. No, he's.
So Principal Duran was participating.
Yep.
Good.
So I'll go. I'm Leah Aldridge from Riverside. So yeah, I am so used to Steve. It's fantastic. I get to annoy him a lot, and I still get to annoy him, which is fun. But one of the things I loved was kind of the reinforcement, because our district has taken some of this already to heart, and we've already we're working towards these things. We're looking at open middle tasks. We're looking at trying to get the kids to try more, looking at conceptual understanding. And so the reinforcement that we're on the right track, it was really nice. And knowing that there's even more that we can do, and then trying to do it digitally. So.
That's great.
Catherine, do you want to chime in?
One of the takeaways I had was just switching it up a bit, using different technologies. Some of my students, they said one of their teachers used this Prodigy math, and it's a video game that you can have special powers by doing math problems. So they thought it was kind of fun. So we tried that in one of the classes, and one kid told me he has no friends, and he says, hey, can we one day do a battle? So I guess to battle the big wizards, you need more friends. So they had a Friday where they all did a big battle, and again, it's all doing math problems to get your spells. So.
Yeah, that's a really great game. That's a really great game, Catherine. Students love it, and it's really engrossing. So and sometimes I think they even forget they're doing math when they're playing that. So
that's fun. One thing that struck me that I share with the team is the role of parents, especially in developing the growth mindset, and how that traditionally we will think that parents are not able to play an important role if they're not familiar with the specific operations or computationals and things like that. But when you're looking at really developing a growth mindset, it's really the role that parents and teachers play, and developing that resiliency and that encouragement for students. So I think that's definitely resonates with us because of the component that we have that focuses on parent engagement.
Right. So while you're talking about parent engagement, about 3 weeks into school, I had this one period that I only have 11 kids in this class, and 8 of them weren't doing work. And we have remind.com, and I used Remind, sent messages, and I send messages about every 2 weeks to parents whose kids are behind. And now that class doesn't have anybody that has a D or an F in there. And so those parents who, I'm not saying whether or not they can do math, my guess is it's a low income school. I doubt many of them can do the math that they're doing, but they can push their kids and tell their kids to stay after school and nag me for help, and they do what they need to do to get their grades up, and they have been. So parents are amazing, even if they don't know how to do the math the kids are doing, and that works in high school too.
Thank you for sharing. Anyone else?
Cindy, we were in room 5, right? I've forgotten the gentleman's name who was there, but Cindy, you're on mute.
It is Hector. Hector.
Yes, Hector.
Cervantes from Orchard.
Maybe Hector's not here anymore.
Yeah, I don't think he's still with us.
Yeah, let me just share just a bit. He talked about the fact that they were starting with ST Math for a lab program that they were doing with their low performing students, and that he was really excited about it because it had conceptual math as well as the computational. He thought that would be really helpful for the kids. So they were just starting that. Any others?
I can speak from group 3. There were 2 of us teachers in there, and we both happened to be from the same school site. I don't know if that was by design or not, but and so the first thing we both kind of mentioned was that it was encouraging to see a lot of common strategies and techniques, things that we're already doing in the presentation, and so that was comforting, I guess. But the other thing that we focused on was that the struggle we're facing now with being able to find the perfect resources to encourage student engagement, to assess students formatively, especially formatively. And so that's kind of where we are right now as a school, is just trying to find the right resources, because we felt like we were in a good place before. You know, we've been using coaching, we've been using, our principal's been very generous with interventions, tutoring, things like that. But now being virtual, it's finding the right tools for this setting.
Mm-hmm.
Thank you, Alfred.
Yeah.
And I'll share for group 4. So in group 4, it was myself and Shawnee and Yumi and Elizabeth. And we all concurred that what really stuck out to us were when we talked about the strategies to improve effectiveness in digital learning, specifically focusing on scaffolding instruction using virtual platforms, where it's not so much of a, here, we have this program, use it, where it's like, well, how are we helping the kids use this platform? And then really working with the teachers about pedagogical strategies that they're going to be using when they're using those platforms, and really seeing it through the lens of the student and how we're applying those strategies. And then, of course, I think it's been mentioned several times, switching it up. I feel like a lot of times we get tied to something, maybe because our district purchased a license for something, or we have to get clearance for privacy reasons and usage to allow the kids, students, I shouldn't say kids, some of them are not so little, where we have to just make sure that we're careful with data breaches and things like that. So it limits our options. And so we often feel like it just may be easier to say, okay, we'll just use this, but they get bored. And if we want to keep them engaged, we do need to switch it up, and we have to find ways to do that. So those were a few of the things that stuck out to us that we talked about.
Great, thank you.
Very good.
I might ask Augustine, and we don't have to have everybody talk, but I would appreciate it if they would put it in the chat or provide feedback for you that we actually had the conversation, or at least I was able to ask Hector about what all of you are experiencing in what students need at home for bandwidth and data allotments in order to participate in your instruction. Now, this is a question that is important for all classes, not just in teaching math, but you happen to be the captive focus group right now. And the reason I'm asking is that Governor Newsom did sign an executive order in August that is titled, his call to action is broadband for all. And we, the California Emerging Technology Fund, by statute, are a member of the California Broadband Council. The Broadband Council is developing an action plan. The first version of that for the first time is due at the end of December of 2020. So it's actually on a very short time frame. And we, CETF, have been asked to compile as much information as possible as to the infrastructure that's needed throughout the state, and particularly at home, for distance learning and telehealth. And so we've asked your districts, we've gotten very good feedback. We've asked County Office of Education throughout the state, but it would be very helpful in informing policy to have this feedback from you as teachers. And so whatever you have, and it can be even anecdotal in terms of, are your students by and large okay with data, with their speeds at home? Or are you getting a lot of feedback about it being the speed not being adequate, download and upload speeds for internet? And also some of your students are connecting, we know, with affordable offers, and some of those, depending on where you are, have data limits in each month, or what the school has purchased will have data limits. So anything you can do to help inform your experience on the ground with your students, real time, right now, would be valued and will help us make the case for significant investment in internet infrastructure throughout the state.
Yeah, I think without getting into the specifics, I have Leah from Riverside Unified and Ms. Kawasaki from Markham here in the Watts area saying that what they have is not sufficient. The people are getting kicked off, and especially if there's multiple children. And we do have that survey question in our school to home student survey. So we have also some feedback per school side on how many students may have hotspots, but are still having difficulty with the capacity. So we'll compile that. So if you have that specific recommendations, or if you want to just confirm that what you have is sometimes problematic, put it in the chat and we'll follow up with you. And, we've had districts say, if we really want kids and families to view content and upload content, we're really looking at 20, 25, even 100 up and down, which is a lot more robust than what they're getting in hotspots. But if you have that kind of feedback, that'd be great. If not, just by you saying that the hotspots is not sufficient, that's also very helpful. So do we have anyone else that's still needing to report? Did we get group 5? Was there a 5th group?
Yes.
All right, go ahead.
Great. Well, thank you for joining. I think that there's a lot in this report, and I think the details are really intriguing, especially what these teachers are saying from the schools that are beating the odds. So I hope you check in a couple of weeks to get the report and take a look at it. And the reality is that many of you are already starting to do some of these things because of the Common Core, and I congratulate you on that. The conceptual learning is not easy, and the whole redefining of what math is to make sure that it's a big idea that's not just computation, but it's the beauty of mathematics and the math and architecture and in the world around them. Plus understanding the concepts that they'll need in order for them to get into STEM careers and eventually contribute to the economy. So appreciate that. And Augustine will let you know when that report is ready. Right, Augustine?